Chemical analysis is an essential component of many industries, from pharmaceuticals to food production to environmental monitoring. There are a variety of methods used for chemical analysis, each with its own strengths and weaknesses. In this article, we will explore some of the most common methods used for chemical analysis. Spectroscopy. Spectroscopy is a powerful method for chemical analysis that involves the use of light to measure the properties of a sample. Different types of spectroscopy can be used to measure different properties, such as the absorption, emission, or scattering of light by a sample. Some of the most common types of spectroscopy include UV-vis spectroscopy. UV-vis spectroscopy is used to measure the absorption of light by a sample in the ultraviolet and visible regions of the electromagnetic spectrum. This method is commonly used for analyzing the composition of liquids and solids. Infrared spectroscopy. Infrared spectroscopy is used to measure the absorption of infrared radiation by a sample. This method is commonly used for identifying functional groups in organic molecules. Nuclear magnetic resonance, NMR, spectroscopy. NMR spectroscopy is used to analyze the structure and composition of molecules based on their magnetic properties. Chromatography. Chromatography is a method for separating and analyzing the components of a mixture. This method works by passing a mixture through a stationary phase, such as a solid or liquid, which separates the components based on their properties, such as size, polarity, or solubility. Some of the most common types of chromatography include gas chromatography, GC. GC is used to separate and analyze volatile compounds. This method involves passing a gas sample through a column, which separates the components based on their boiling points. High-performance liquid chromatography, HPLC. HPLC is used to separate and analyze non-volatile compounds. This method involves passing a liquid sample through a column, which separates the components based on their chemical properties. Thin layer chromatography, TLC. TLC is a simple and inexpensive method for separating and analyzing the components of a mixture. This method involves placing a sample on a thin layer of adsorbent material, such as silica gel, which separates the components based on their chemical properties. Mass spectrometry. Mass spectrometry is a method for analyzing the mass and composition of molecules. This method works by ionizing a sample, which produces ions that are then separated based on their mass-to-charge ratio. Some of the most common types of mass spectrometry include electron impact mass spectrometry, EIMS. EIMS is used to analyze the structure and composition of molecules by ionizing them with high-energy electrons. Matrix-assisted laser desorption/ionization mass spectrometry, MALDI-MS. MALDI-MS is used to analyze large biomolecules, such as proteins and peptides, by ionizing them with a laser. Liquid chromatography mass spectrometry, LCMS. LCMS is a powerful method for analyzing complex mixtures of compounds. This method involves separating the components of a mixture using chromatography and then analyzing them using mass spectrometry. Electrochemistry. Electrochemistry is a method for analyzing the properties of chemical reactions that involve the transfer of electrons. This method works by measuring the electrical potential and current generated by a reaction. Some of the most common types of electrochemistry include